Bill Nye the Science Guy.
This is real, and for once, the truth is scarier than fiction. A topic which at first seems harmless enough, now is pretty important to what we do every day. But it's dangerous. Dangerous enough to be a weapon. Dangerous enough to do some real damage. Dangerous enough to blow your skull. So crack up those speakers if you dare, as we prepare to talk about a killer that is both silent and deadly and not a fart. It can happen to you at particularly any moment without you realizing what is going on. But in order to understand that scary little thought, we have to review the basics of sound first. So let's start at square one. What is sound? How can something invisible possibly cause someone's head to pop like a 16-year-old's pimple? Well, sound is a bunch of pressure waves, vibrations that travel through air or water or anything really. I snap my fingers and I cause the air around my fingers to vibrate, like ripples in a pond. Those ripples eventually reach my ears, allowing me to hear the sound of the snap. That's why in the vacuum of space, no one can hear you scream. Literally, there's nothing there to vibrate, thus carry a scream sound. Or a gunshot sound. Ghost Cod, you hear me? I'm looking at you. For as cool as these scenes are, Isaac Newton just face-palmed all over this game. Since sound is a pressure wave, it most often gets represented like this. Now, there are 4 different numbers you can use to describe a sound wave. Wavelength, period, amplitude, and frequency. Well, the one that's going to help us right now is frequency, which means how many vibrations or ripples there are per second. Say I pluck a string good and hard. My pluck starts in the position, and the number of times the string reaches that position again in a second can be said to be the frequency. This speed in turn affects the pitch of the sound. More vibrations per second means higher pitch, and less means a lower pitch. This number of cycles per second is measured in hertz. Like the rental car or the donut. Hertz? Donut? What? Now, for anyone who has ever used a dog whistle knows that the human ear can't hear all the frequencies of sound. Now, the sound leaving the drives the dogs crazy sounds like nothing to you, but the frequency is too high for the human process. There are also sounds that are too low for human hearing. In general, you can hear frequencies between 20 Hz and 20 kHz. Anything below that 20 Hz threshold is called infrasound. And though we might be able to hear it, it can certainly affect us in some pretty bizarre and disturbing ways. Now, I have to ask, do you trust me? You shouldn't, because I'm about to play you a very brief example of infrasound. Don't worry, you'll be fine, or at least you should be. Did you hear that? Or should I say feel that? You probably didn't. That's because most of headphones or speakers can't produce that low of hertz. It's called frequency response. The range of frequencies a set of speakers or headphones can produce. That said, for those who heard it, it probably didn't sound like much, but chances are you probably almost felt it. The low frequency sound means it has a longer wavelength, which makes it easier to penetrate your body and shake things up. The weird thing is that almost any part of your body, based on its makeup, will vibrate at specific frequencies. This is what it's known as its resonant frequency, the tone at which an object, in this case body part, vibrates the most. Take for instance your eye. It has been documented that when placed in a room with a fan resonating at a frequency of 19 Hz, almost the exact frequency of the human eye, test subjects said that they started to see ghostly gray shapes floating in front of them. When the fan was removed, the shapes faded away. Here's another example. At Brown University there used to be an elevator to hell. An assumingly harmless elevator with a bent fan that produced an undetectable infrasound. Going as low as 2 floors, ended up with the rider feeling nauseous. All of this is what known as vibral acoustic syndrome, the effect of infrasound on the body, but not on the body, but on the various fluids throughout the body. And do you know what else is a fluid-filled part of the body? Your head. All objects have limits to which they can stretch when subjected to force. So if you can find the right frequency and put enough power behind it, the head will stretch and stretch until it can't stretch anymore, resulting in fatality. For sound, this comes down to a matter of decibels, the measure of a sound's loudness. For example, a quiet garden, about 30 decibels, a chainsaw, 110, an iPad at max volume, 115. Your cry of anguish when you were at the last boss and you get killed by that one unfair attack that you just can't dodge, damn it, 165 decibels. Actually, that's not true. That's more along the lines of firing a shotgun beside your ear, but it's relatively the same. Anything above 125 is going to cause you pain and potentially hearing loss. But because of the frequency of sounds, we know that they are loud and that they hurt and we should avoid them. The scary thing about infrasounds is that since we don't hear these frequencies very well, we are often unaware of how loud they are. Put it this way, you could be hearing destructive levels of infrasound without actually hearing it. All that high-pitched screaming Cinderella is doing is totally unnecessary. You would be feeling this bizarre pressure coming from somewhere you don't even know. Specifically, this is what you will experience. At 130 decibels, the inner ear will be experiencing distortions, which will affect your ability to understand speech. At 150 decibels, you will start complaining about nausea, the whole body vibrations. By the time you reach 166, you will notice problems breathing because the low frequency pulses will start to affect your lungs. Upon reaching a critical point of 177 dB, when infrasound point from 0.5 to 8 Hz can force you to breathe against your will. That's right. Sound can literally be controlling your body. So really, we could kill you by simply stopping your breathing, with the equivalent of a prolonged shotgun blast. But if we really wanted to show off about it and pop your head like a firework like that scene from Scanners, we'd have to crank up the dBs to something substantial like 240, since the head is so well insulated. Behold, LROD, the long-range acoustic device able to focus a sound into a concentrated beam and project it loud and clear for over 2 miles. That's more than I could run. Ever. This thing is like a sound launcher, so powerful that one of its key selling features is to equip it to a helicopter and shoot at the ground and still make people cringe to the ground. That's no joke. You can literally hook up your iPod to it, and that includes infrasonic tones. Add that to this fact. Bullhorns operate at 90 decibels. This guy can reach 162 dB without breaking a sweat. That number is well over the limit of causing prolonged hearing damage, and only 4 shy of causing breathing problems. Turn off the safety switch and who knows what could happen. There is not actual documentation on the limit. This bad boy has been used on protesters and pirates, not those. These. Captain Felix would have been a much shorter movie with some LRAD. Of course, it can save lives, making enemies surrender without firing a bullet. In fact, it has been used as a defense mechanism against soldiers, which is great, but then you have it being used against peaceful protesters, trying to exercise their rights of free speech. Not so good. In the wrong hands, you would have a silent helicopter-mounted headburst. So yes, just like in Mortal Kombat, this is a real thing. A really scary thing. A silent, long-distance killer that is much scarier than a dead-eyed bride of Frankenstein ripoff. So thanks for listening, because this time you had a choice.
Prepare to see the coolest video you'll watch all week. Wait, you're already watching the coolest video. The second coolest video you'll watch all week. So what's with this magical illusion? What we have here is an example of flux pinning, which all depends on deep penetration. Penetration by magnets. So a superconductor is a material that, when cooled below a certain critical temperature, is able to conduct electricity with zero energy loss. In other words, if I added some electric current into a superconducting wire and removed the power source, the electricity would continue to run through the wire forever, which is awesome, unless you're a magnetic field. You see, the other property of superconductors is that they expel any magnetic fields going through them. This is called the Meissner effect. But some superconductors, like this one, are so thin that magnetic fields are able to penetrate them. They just do so in incredibly tiny amounts called flux tubes. For a disk this size, there are nearly 100 billion flux tubes, able to hold 70,000 times the conductor's weight. At such low temperatures, the flux tubes become pinned and can't move, which is how the disk levitates in space.